Welcome back to another FastAPI. Not technically FastAPI, it is a Redis video. In the few videos before this, we'll just learn about Redis, like theoretically about what it is, stuff like that. Also, I have a bunch of links to it. Let me just open the links real quick. Yep, we are back. So this is one of those tutorials they had using Redis with this. Also, Redis FastAPI SDK was released a few days ago, which I was talking about in the, yeah, I think this was a few days ago. So yeah, so we'll pretty much be looking at this as well, official fast API integration for Redis. But before that, we'll be just doing this video, which I didn't do this because I spent most of my time. Redis is build pro, that's so interesting. But yeah, we'll first try to get a hang of the command line. Even though I have some idea, we'll go through this entire video, which I have gone through a little bit, but we'll go through this again and learn it. So let's go. um,
and with an H. So if we want to set a value, we could
that
say
we have
H set.
done this a bit, but I guess I forgot, so I'm just gonna redo it again.
Installing Redis on your computer is really simple if you have a Mac or a Linux computer. If you use Mac, just use Homebrew to do the install, and if you're on Linux, just use your package manager of choice to install it. It's just called Redis. It's that simple. But if you're on Windows, it's a bit more complex because there is no way to install Redis on Windows. Instead, you need to go through the Windows subsystem for Linux, which is pretty simple to install. I'll include a link down in the description on how to install it. And once you do, essentially you can run.
Interesting, because Redis is, by the way, guys, let's also have background noise, because that's the combination we go with. Yeah, go dead theater. Yeah, so let's have this in different tab. Yeah, so pretty much because Redis is optimized for Linux, running it via is the most robust environment for backend development. Open PowerShell as administrator, run this. So run the following commands in the Ubuntu terminal to add Redis repository and install it. So okay, so it seems like this is how we do it. Let's go through this. Yeah, so I think I'm running Ubuntu. Yeah, this is Ubuntu server. As you can see, this is Ubuntu. If I do nano fetch, what is it? How to know the distro name via WSL? It's Ubuntu. Okay, I know that. WSLL. What? Um, yeah, oh wow. Ubuntu. It's Ubuntu chat. Okay, it's Ubuntu. The first thing we do is we curl this. So, I think, yeah. Was that simple? No. Enter new file. No, I didn't mean to. Override. Okay, wait a minute, chat. I think I'm doing something wrong. Yes. Okay, and so then we do echo this. Okay. Okay, I think nothing is going wrong. Hopefully, hopefully. Um, okay, that seems to work. And then we can do sudo apt get. Um, after this operation, yeah, sudo. Okay, so it seems like it's built, and then I can do sudo service redis server start something else demonize. Okay, let's see this.
Run Linux on your Windows machine super easily. So as you can see, I am currently inside of a Linux terminal using the Windows subsystem for Linux on my computer. In your password, this is going to get it downloaded, so it's pretty quick. And then once you get it installed, just type in redis-server. This is going to start up your.
Oh, server. Oh wow, this is so cool. So now I essentially have Okay, so it seems like I have my server, right? PID is that monotonic clock address, and it's listening on port 6379.
So it's pretty quick. And then once you get it installed, just type in Redis dash server. This is going to start up your Redis server. And as you can see, it just prints out a bunch of information and it says running in standalone mode on port 6379. And that's just the default port for Redis. So now Redis
Oh,
is running on port
wow, okay.
6379. So in order to access Redis, we just need to open up a new terminal. And if you're on Windows, make sure
What it's saying to me, warning, could not create server TCP file already in use. Um, mm, okay. What? Localhost Redis. Um, I guess I'll delete this. Let's go 1116. Wait a minute. Um, how do I stop Redis server in WSL? I think it's already. I think in the part of the process where I was installing it, it installed it. Redis server stop. Um, okay. Okay. So now if I do something like, okay, so it seems like now it works. So I think during the process it was does not require authentication. My local client. Yeah, I mean, sure. So yeah, it sounds working.
open up a Windows sub Linux terminal here, and then we can just type in Redis CLI. And now we can actually access Redis and run commands kind of like you could do in Node with a CLI. So for example, one thing that we could do inside of here is just type quit and that exits us out of the CLI.
Oh, wow,
Obviously we want to be in the CLI though. So the very first thing we can do is add things to our database. Because like I said, this is a key value pair database. So the
crazy.
main things that you're going to do is setting a value for a key and getting a value for a key. So
So as far as I understood, the entire idea behind Redis is that it's a key value store, right? Somewhat, you could think of this key value store if you're from Python, like ticked, from Java hash map. If you're from C, then God knows. So essentially, you have just bunch of keys over here, and those keys map to some type of value. Now, those values could be as simple as a string, could be as simple as an int, could be as simple as these primitive data types as like, or they could be like a linked list. Also, by the way, the implementation of an array is like a linked list. It could also be to one hash map, or it could also be to a JSON, right? But this depends on this key value, and as you know, key can be unique, right? Stuff like that, you know the
So we
rules.
can type in set, and it can be all uppercase, all lowercase, it doesn't matter. Generally, the
Oops.
idea though is to use all
Oh wow.
capitals. Then we're just going to type in our key. Our key is just going to be name, and we'll put in a value of Kyle. And then we hit enter, and you can see it said OK. To
Okay.
check to see if this worked, we can type in get and the name of our key, which is just name. And as you can see, we get the value of Kyle being
Oh wow,
returned
can
back
I
to
do
us.
some?
Now you'll notice something about Redis is that pretty much everything you store inside of Redis is going to be a type of string by default. So if we
Okay,
set, for example, age equal to 26,
so
and then
that
every
means it
time we're
was
going to be get
successful,
our
right?
age, you're going to notice it comes back as this kind of string type. Technically, Redis is smart enough to know this is an integer, but it really doesn't matter because when you're accessing and dealing with these
Alright,
things, they're pretty much always going to come back to you as strings when you're
first
dealing
one.
with Redis. Now with Redis, we can also do a delete. So I could say, delete age. And now if I do get age, you can see it returns to me null here because there is no age at all because I deleted that key. So we can set keys, we can get keys, and we can delete keys. And finally, we can also just have this command called exists. And this is just you type in a key, for example, name.
Oh,
So
okay.
if I spell name correctly, and you can see it returns to us 1, saying that this is true. And when I typed name incorrectly, it returns 0, which means false. So you can determine whether or not this key exists or not. So that's kind of like the most basic things that you can do inside of Redis for setting, getting, deleting, and checking if they exist. Also, what you can do is check to find all the keys that match a certain pattern. So if you just put star, this is going to get you all the keys. Right now, we only have one key, which is name, so that's why it's returning to us name.
Oh,
But what
okay.
this is going to do is check to find all the keys that match a certain pattern. So if you just put star, this is going to get you all the
So like
keys.
wildcard,
However,
yeah.
we only have one key, which is name, so that's why it's returning to us name. This is a great way just to see what's inside of your database. You can also get rid of everything in your database by just typing flush all, hit enter, and now when we check our keys, you're going to notice we have no keys at all. And this is a really great way to just clear everything out. If you're having problems with your caching, you can just clear the entire cache, and now there's nothing at all inside of it. But I can go back and I can say set name Kyle, and then I can get name, and as you can see, it's returning to me that name. Also, if you want to just clear out the input, just type the word clear. That's going to clear everything out for you. And then a few additional things that I really want to talk about is the idea of expiration. So if we just type
Yeah.
in TTL and then the key name, which in our case is name, this stands for time to live. And as you can see, this time to live is -1. That just means it has no expiration at all. It's going to live forever. But you can actually make keys so that they expire at some point. I could, for example, type in expire and then name, and I want it to expire in 10 seconds. And now when I check the TTL for name, you can see that this is constantly counting down. And once it gets all the way down to 0, it's going to completely delete this key. So as you can see, 1, now we're essentially -2. -2 means it is gone. Now, if we do get name, you can see there is no longer anything for this name key because we'd expired it after 10 minutes. And if you want to make sure a key expires when you set it, you can use the command set ex, and that's going to give you a key, in our case, name. We can give it how long we want it to last, let's say 10 seconds, and then the value of Kyle. So it works just like set. We name key because we'd expired it after 10 minutes. And if you want to make sure a key expires when you set it, you can use the command set ex, and that's going to give you a key, in our case, name. We can give it how long we want it to last, let's say 10 seconds, and then the value of Kyle. So it works just like set.
Oh, this is some dumb crap. Oh my bad. Set ex. And the moment you do that, you would key start empty area. So right, so cool.
But you can actually put the expiration right here. And now when I TTL that name, you can see it's constantly.
Oh, no, no. What am I doing?
Counting down from 10, and once it gets all the way down to 0, it's going to delete that key. Now that covers most of what you're going to be doing inside of Redis, since you're mostly going to be dealing with strings, but Redis also has support for handling arrays in the form of a list, and they also have hashes for kind of storing like JSON objects. So let's take a list first. In Redis, if you want to add an item to a list, you're going to say L push, and this is going to add an item to the start of your list. That's what the L stands.
Oh, while Redis list behaves exactly like a doubly linked list. That's interesting. To ensure all one push and pop operation work, actual quick list. Yeah, that's true. The memory requirements is low. Interesting. What is zip list? What does that mean? Singly linked list. So chat people who skip their data structures class, this is what a singly linked list is. So you have a node. Technically, you have a node which contains a value, right? Contains the data, and then contains a pointer to the next node, right? And this next node, I mean, we draw it like this, but this next node could be anywhere in memory. That's why it's so uncache friendly. So data, and this could point over here. And if it's pointing at the end, you can just say none. None is technically the zeroth address. Many people don't know that, but yeah, so this is none. Doubly linked list is, as you can understand, is very simple. You have data, you have one list that points forward, and then you have one list that points backwards. So you will have one, this will also point nowhere, but essentially you have these things. So one pointing forward, and this is useful when you want to traverse both directions. But again, you can see how in a 64-bit system a pointer takes 8 bytes, right, which is space, right? So that space storage goes high. This is regularly duplicate. This is not, yeah, previous. So before storing one character, I've already sent you. Exactly, that's the point, right? So whenever you do doubly linked list, even though you're providing yourself capabilities of traversing both in both directions, your space complexity kind of sucks, right? Which kind of becomes zip list. In order to imagine the list, instead of allocating one node for each element, it just stores everything inside one contiguous chunk of memory. More realistically, interesting. So apparently, as far as I understood, instead of saying well one and then storing next and 2 and then storing next, because over here you have already used 8 8, forget about this, you have already used 16 bytes. They say okay fine, hell this 1 2 and then this, right? So it's okay, bro, Redis is kind of interesting. Can you show me some pictures? I want to see some pictures. I'm deviating off the topic, we might want to learn this because it's kind of interesting.
So one of the data structures that Redis supports is list. Now, if I would want to create a list, it's as simple as I can just directly start writing lpush, which is basically pushing something to the list.
I want to do this, so we'll go through that again, but right now I don't want to because you want to do this.
Stands for left or start.
So now we can have list specific operations, right? So if we do l push,
So we can give our list a name, which is our key. Let's just say friends. And then we're going to give this thing a value that we're pushing on. So let's just push on John here. And now we have a key.
Okay, so apparently what this is happening is if we say something like L push, so we say key star, no key, so we do L push um, friends John, and then we say keys, we get keys, and we say, well, get friends. Warning, operation against key holding the wrong kind of value. Interesting.
type. We can't get this, and that's because get only works for strings. If we want to print
Exactly.
out a list, what we need to do instead is say L range. Then we say friends, which is the key that we want to get, and then we say we start at index 1 and stop at index -1. That means get all the items in the list. As you can see, we get John being printed out because that's the only thing in the list. Let's put
I'm assuming there's something called rpush, so L range. This is something like okay, done. Done.
Push another item to the left or the start of our list. We can say L push inside of friends because that's the name of our array. And we can say we want to push in Sally here as well. And now if we get all the values, you can see Sally got pushed to the front and then John got added on. Also with these lists, you can push on the end or the right hand side by using R push. It works the same way as L push, but it's going to add it to the end of the array. So let's put in here, Mike. And if we check this, you can now see that Mike got put onto the end of the array. You can also take items on and off of the array by using something called L pop and R pop. They are going to be the left and the right hand pop. So L pop, you just type in friends, and it's going to take the first item on the left or the start of our array, take it off, and return it to us. So it took Sally away from the array, returned it to us, or the start of. So L pop, Mike got put onto the end of the array. You can also take items on and off of the array by using something called L pop and R pop. They are going to be the left and the right hand pop. So L pop, you just type in friends, and it's going to take the first item on the left or the start of our array, take it off, and return it to us. So it took Sally away from the array, returned it to us, and now if we look at our array, you can see Sally is gone. If we do R pop of friends, and we now print out our array, you can see it got rid of Mike, which was the last item in our array, so it took out the thing on the right-hand side. A list like this is really useful for any type of queue or stack that you want to have. Like, let's say you have a messaging app and you want to cache the 5 most recent messages from a user. Well, you can constantly just push on to that array, so you could do like an L push to push onto the top of the array, and then you could do an R pop to remove the last item. That way you always make sure you have 5 things in there, and it's going to be the most recent 5, and once you get a newer item, it's going to push off the oldest one and put this newest one right on top of it. That'd be a great use case for this list type. The next thing I want to talk about is sets, and sets are very similar to lists because they're like an array structure, but it's a unique array. If you know anything about sets inside of JavaScript, which I'll link up a video I've done on them up in the top right in the cards, the set is essentially just a list that is completely unique. Every value in the list is unique, and it's not put in particular order like an array is. So if you want to create a set, you have to prefix everything with S, so we could say like S. Add, and we can give it a key, and let's say here that we have hobbies, and inside of here, we're going to pass in a value. This is very similar to like pushing to.
Interesting. So I could say something like keys. What am I saying? Um, L push, my bad. L push friends. lpop, rpop, l index. I don't know why that's l index. Should be something like index. To be honest with you, l range. R push. So left. So NOI. Then yeah, that makes sense. Mango. Okay, so I do something like keys. I go flush all and go keys again. So I will say, right. So now keys. I'll say that. I don't think you can get fruits. But I think it's gonna be doesn't look like that. Yeah. So again, we have added that. So very sad fruits. Apple. It will say, oh wow, interesting. Key star. We do flush all. We do sad fruits apple. Sad fruits apple. But it doesn't really add it. If I do mango, it does add it. Okay. S members fruits. S members, right? Okay, so this should work. So yeah. Okay.
To an array, but we're adding to the set. So let's just push in here the hobby of weight lifting. And you'll notice I wrap this in quotes if I have more than one word. So now if I want to get all the things inside of here, we can say S members, S members, and this is just going to print out everything inside of that thing. So hobbies is the thing we want to check, and as you can see, we got all the values inside of hobbies being printed out. And like I said, with sets, it's essentially completely unique. So if I try to add weightlifting back in here again, you can see we got 0 being returned saying that it was a false. It could not add this because it's already there. And if we check, you can see it didn't add it. We only have just that one thing inside there, weightlifting. Also, with this, we can do a remove. So we could just say srem, that stands for remove, from hobbies, and we want to remove that value of weightlifting. And now if we check our members, you can see that it's an empty list. There's nothing at all inside of it. Now finally, I want to talk about hashes, and hashes are just another key value pair. So you can think of it as like a key value pair inside of a key value pair, but with hashes, you can't have hashes inside of hashes. So it's like a JSON object, but you can't have any nesting at all inside of it. It's just one set of key value pairs. So to do anything with hashes, you're going to prefix every command with an H. if we want to set a value, we could say a age set. And let's just say that we want to have a person. The field we want to set is their name, and we want to give it the value of Kyle. So now what we can do is we can say h get, and we want to get person, and we want to get the name from that person, and you can see it.
What the hell? What? So I can, let's say, I can say keys, say flush all, and we can say h set person name one this Atik rar alam then age so 20, and then we say h get all person h set person name. Okay. Okay, it's a bit
Say
confusing
each
there.
get, and we want to get person, and we want to get the name from that person, and you can see it return.
So h get is pretty much h get. Okay, so let's say I want to say h get person ka name and age. Only one.
Turns to us Kyle. And if we wanted to get everything about that person, we could just use get all, type in person. Now you can see we have the key name.
I think everyone should make a cheat sheet like this because I guess writing something reinforces that thing. I mean, for me, yeah, it's more writing that. Uh,
name and the value of Kyle. So it prints out the key first and then the value second. And we can add other things. So if we go back to age set, we can instead set an age. So let's say that we want to do an age set for a person. We want to set the age, and we're going to set it to a value of 26. Now when we do a get all, you can see we have a name of Kyle, and we have an age of 26. And we can get individual properties. So for example, I could say, get just the name, or I could say just the age for that person. Or we could do that get all again and get all of the different key value pairs. You can also do an HDEL, which is going to be a delete. So let's say that I wanted to delete the age property, and now I printed everything out. You can see that
HDL. HDL is key. Can delete one or more fields from a hash. Right, so let's say I don't wanna, let's say over here get h call, I don't want to have that, so I can say h till person age and name, but h get all is nothing, right? So pretty much example would be HDL person name, or you can say HDL person age. I think this age. If I run this again, it's integer 0 because it doesn't exist. Interesting. So let's have h set person name, right? And so we get h get all for person. Get this. Great. If I do h tell person and I go name, I go age. It does give me one. And if I do h get all, it does key star. Great.
There's only the name right here. And also I could do an exist. So I could say h exists. And I could say person and name, and you can see that returns true with the integer of 1, and age returns false with the integer of 0. So hashes are essentially a great way if you need to store like key value pairs inside of an individual key. But like I mentioned at the beginning, almost everything you're going to be doing inside of Redis is going to be dealing specifically with a string. So you're going to be doing like sets and gets and expirations, and that's like 95% of what you need to do inside of Redis. So speaking of that, let me show you a real-world example of how you would take Redis and implement it inside of the backend of an application to speed it up by about 10 to 50 times. So here I have a really simple Express Node.js application with two different endpoints. One is
So
for
that
getting all
was
of the
pretty much the entire Redis CLI tutorial, so to speak. 20 minutes, and then he's going to show us an example which I am going to watch. Even though Node.js is not applicable to my situation, I am still going to watch it. So let's go.
the photos, and one is for getting an individual folder. And in each one of these endpoints, all that we do is we call out to this JSON placeholder API to get a list of photos, or we call it to get an individual photo. And here we also have the option to API to get a list.
So as you can see, we have one endpoint, one endpoint which is slash photos, which is a get request which returns you a photo. I'm assuming this returns you tons of photos, and then you have another get request which where you can specify a single photo. Okay, and that's what he said.
Two different endpoints. One is for getting all of the photos, and one is for getting an individual folder. And in each one of these endpoints, all that we do is we call out to this JSON placeholder API to get a list of photos, or we call it to get an individual photo. And here we also have the option to pass it an album ID to just limit the size of the list. And this code, you can just imagine this right here could be anything. It could be calling a database, calling some other API. This is just like your main code that runs inside of your server. And this is pretty slow code because there's a lot of data to fetch, and it's calling out to an API, which is always going to be pretty slow. On the right-hand side here, we have my own version of Postman that I created. If you're interested in learning how I created this, I have a whole
Wow.
video on it linked up in the description for you. But if we just query out to HTTP localhost 3000, which if we scroll down here, that is what this server is running on, and we go to /photos, and I click send here, you can see down here we get our response, which has a ton of information inside of it. As you can see, there's essentially 35,000 lines of code inside of here being returned, and it took about 370 milliseconds. And if I do a few more sends, you can see it's around that ballpark of about 300 to 400 milliseconds every time I make this request. And if I get an individual photo, for example, photo 1, click send, you can see it's quite a
Yeah,
bit
of course
faster,
it's
it
free.
uses a lot less data, but it's still taking, almost 100 milliseconds for this to run. And this photos one is taking quite a while. Like I said, 300 to 400 milliseconds. Now this 300 to 400 milliseconds isn't like the end of the world, but you can imagine a query that takes much longer, maybe 1, 2, 3 seconds to run. And if you have to wait for that every time you load your web page, obviously that's a terrible user experience. So instead what we're going to do is use Redis to cache this information, so that way whenever we make a request after it's been cached, we're going to get it directly from Redis, which is going to be way, way quicker. So let me just come in here and we're going to install Redis. So I'm just going to open up a new tab here. I'm going to say npm I Redis, just like that. It's going to go through, it's going to install Redis for us. Let's go back to where we were before. Now we have our application running, and we can import Redis. So we can say const Redis is equal to requiring of Redis. And now that we have Redis here, this is actually going to be essentially like a class that we can use. So we can get an instance of Redis. So we can say that we want to get our client, which is just saying redis.createClient. And inside of here, we can just pass it nothing, and it's going to use all the default parameters or you can pass it specifically a URL. So if you're going to push this up to production, you're going to want to pass in the URL for your production instance of Redis. But for our case, we're just using the local host version that's running on the default port. So we can just leave this completely blank, and we actually have access now to Redis. So to make sure that Redis is running, I have a Windows terminal open up over here for Linux. I can just type in Redis server, and that's going to start up Redis. And if we just expand this a little bit, you can see that it's saying it started up Redis, and it's saying that it's accessible. So let's just minimize that back down a little bit. Let's start up our server. We'll say run dev start here, just like that. So our server is running, everything's working, and we have this Redis client. I'll even just rename this to Redis client. Now, in order to use this Redis client, you're going to use it just like you would use normal Redis. So if we come down here, we can say like Redis client.set. That's going to allow us to set. Or we can say set ex, and that's going to allow us to set with an expiration time. Every command I just taught you in Redis is going to, and we're going to say, for this, we want to set something for all of our photos. So we're going to set it with a key of photos like this. And we want to set an expiration. Let's just say that we're going to create a default expiration up here. So we're going to say
So the format is somewhat like set ex.
a const default expiration is just going to be like 3,600 seconds. That's essentially the same as 1 hour. So there's our default expiration. And our value for this is going to be the value we get from right here. So let me just bring our default expiration, and our value
It takes a second, which is just a number. Interesting.
for this is going to be the value we get from right here. So let me just bring this down a little bit, and we can say that we want to store the value of data inside of here. Except for this data right here is an array of values, and inside of Redis we can only really store strings. So we need to make sure we json.stringify this to convert this into a string to store it inside of Redis. Now if we save this and we just send on our page here, what's going to happen is nothing new is going to happen. You can see it's still taking quite a while to do this command, but now we're storing our information inside of Redis with this expiration here, and we're storing this data. So what we can do is we can essentially go over, open up a new terminal tab here. We can say Redis CLI, and we can just say keys star. And as you can see, we have that really great, but right now we're not actually getting that information because 1,000 lines of JSON. Now that's really great, but right now we're not actually getting that information because every time we run this, we're just getting the data and saving it to Redis. What I want to do instead is check, does Redis have this information? And if so, skip essentially all of this code right here. So we can say Redis client.get, and what we want to do is we want to get something with the ID or with the key here of photos. And then this is going to take in a callback that has an error, and it also has our data. In our case, our data is just all of our different photos, but they're going to be as a string. So what we need to do is if we have an error, then I just want to essentially console.error out the error. Now the next thing I want to do is check to see if we have some photos. Some data return red, but this is returned to us as a string. So if we have photos already saved, just return them down to the user. Otherwise, what we want to do is we want to get that data and we want to set it. So we want there, and then obviously we're going to make sure we just JSON that information down. Now all that we've done inside of here is we've wrapped everything inside of this Redis client get, and if we're able to get information, we return it immediately. Otherwise, we go through, we query our database or API, whatever it is. Interesting. It looks like when I click send, nothing worked. So if we come over here, you can see we have an error. If I scroll up, it's just saying that this await keyword is not able to be used, and we need to be inside an async function. So let's just make sure this is an async function right here. Now, if I save, you can see we no longer get any errors. We click send, and you can see the time is now 63 milliseconds. So we went from 400 milliseconds down to 60. We click send again, now we're down, 37 milliseconds. It's super, super quick. And that's because we're just pulling this directly from our Redis cache. If I just put a simple console log inside of here that says cache, we're going to print out cache miss. If we come over, we're hitting a cache every single time. That's where this cache hit is coming from. Now, if we come over to here, to here where we have our CLI open,
And
we
it's
say
like,
flush all. That's going to clear out our entire database. We now no longer have that key, as you can see. So if we go back here, we should see that when we first search, it's going to give us a cache miss. And of course, it's giving us an error. Let's see what this is. Just saying data is not defined. We have data here, data here, data here. We just need to move this inside of the else. There we go. That should fix that error. So now if we just make sure we clear that back out again, let's just, clear everything. Go back over to here. And now we click send. You're going to see said cache miss
yeah.
400 milliseconds, so pretty slow. We click send again, it's a cache hit, and now it only took 36 milliseconds. That is way, way faster. That's 10 times faster immediately right there. And we click send every single time, it's going to be a cache hit. Now, one problem with this initial setup, though, is it doesn't work with this album ID. If I add in a query param for our album ID, and let's just say we do album ID of 2, and I click send, you can see I still get all the albums with ID 1, the albums with ID 87, and so on, and that's because it's still hitting this cache of photos. We need to make sure that our cache key takes into account everything that could change. So, for example, if the album ID changes, we want this key here to change. So what I would like to do here is essentially just add in our album ID, and we're just going to put the value of that album ID onto the end of our key. So now our key is for any photo that has an album ID or doesn't have an album ID. The only other thing we have left to do is make sure we use the same key. If we can't get to that key, we're going to trees. You just
I
add
mean,
the
that makes
namespace.
sense. What is Kafka, by the way? Like, I never know. Oh, I think we'll watch it out. Just watch this. It's very interesting.
And that is very.
How do I stop this? Because I am assuming. Okay, so it has stopped now. Finally, so it has stopped. Wow, so it's pretty much like a.
Fast. And so you don't have to have a bunch of latency that you insert into the process. I'll start with Z, and their syntax very reliably. Something simple is great. So far, we've talked activity to the. So the sorted set commands all start with Z, and their syntax is quite simple. I give a key, the ranking value, in this case, the number of likes, and then some string identifier. In this case, I'm going to have the tweet ID, call it some ID 1. This first tweet, let's assume it's a tweet about Tiger Woods. In the next tweet, we're going to do the same thing, but for some ID 2, this might be a tweet about zoo tigers, and we're going to add the ID 1. Remember, I call these sorted sets, which means for any given ID, it can only have one. Then every is that each of these longitude
I mean, he's trying to show it.
need to be able to address one another in a reasonable fashion. Canonical example of this would be a chat room, where unique instance where your servers need to be able to address. The last capability of Redis that I'm going to talk about today is PubSub. And PubSub is really trying to solve for this unique instance where your servers need to be able to address one another in a reasonable fashion. Canonical example of this would be a chat room, where user 1 is connected to server A, maybe via a WebSocket or some persistent TLS connection, and they need to message user 3, who unfortunately is connected to server C. How does server A know user 3 is on server C? There's a bunch of different potential solutions to this problem. Probably the most famous is to use a consistent hash ring, so that way user 3 is always allocated to server C, and server A knows that, and so can send messages directly there. But there's a bunch of incremental problems that happen with these consistent hash rings. Notably, it's harder to manage the balance between servers, and scaling them up and down requires a bunch of very careful orchestration, usually with a service something like Zookeeper. But Redis has this capability called PubSub, and the idea with PubSub is that the servers can connect to Redis and announce a publication that they're going to be making. And then on that topic, other servers can subscribe. So if, for instance, user 1 connects to server A is going to tell Redis that I have user 1. Any messages sent to the topic for user 1 should come back to me. And server C would do the same thing. Now, when server A wants to send a message to server C so that user 3 gets it, what it's going to do is publish to the topic of user 3. Redis PubSub is at most once delivery. So the idea here is that the message might get to a user and it might not. now register its
Okay, buddy.
application to that
I'm gonna leave this for some other day, but yeah, great. So that was great. Um, I'm a bit tired, but we learned about all of that. Let's just look at this. Let's just read through this. FastAPI is a Python web framework based on the Charlotte micro framework with a deep support for async IO. FastAPI is indeed very fast. FastAPI also distinguishes itself with like automatic OpenAI document your API. Just by getting started guide first in this tutorial. Okay, I don't know. Oh wow, so I'm fine. Oh wow, they opened a Jupyter lab. That's crazy. Embracing it. Look at some of the tests. Um, test test data. Oh wow, we have test data as well. JSON test data. Oh my god, it's like a beauty. Right, anyways, let's see this. So we have import Redis. Um, notebook is read only. Come on. Okay, so and this is the hash set. This is setting this to this, and we say mapping is equal to this, and then we run this, and we say, oh wow, does this work? Something like, how would I? Oh wow, that's fun. Hmm. What if I do something like r dot get something I didn't even put? Let's say bar. I return this. I should. Um. Oh, man. This has to be run once, right? Why is this? Come on, I'm not getting a response. Come on, give me a response. No, I don't want to. Okay. This is interesting. So we do user sessions. This is the key, right? It's very much similar to doing something like um, Redis. Oh, no, this is not. I can't do this way. This is gonna be. Yeah, of course, I can't. Kali. Okay, so we do Redis CLI. What? Are you for real, man? What? Oh, okay. So yeah, it's pretty much similar to doing etch set, and you set this as user session 123, and you say well name is equal to John, and then you say surname is equal to Smith, and then you say company is equal to Redis, and then you say age is equal to 29. So we did 4 values, right? So we did 1 2 3 4, and we say h get all, right? H get all of user session, and we get all of this. We can get h get, right, user. We can set h get, and let's say we only want to get the companies working at, so we can get Redis, right? Say key star, what key star, my bad, and say flush all. Okay, that's pretty much it, and we do r dot close. I'm assuming. Wait a minute, so we have learned that. I have learned it. I guess we'll implement this tomorrow. Storing application data, sure. Pretty much everything. I'm not familiar with this thing. What? Prerequisites are killing me, boss.
Hi, this is Łukasz from HDB, and I'd like to invite you to a series of short videos where we present some parts of our tech stack. In this particular series, we're introducing asyncio, a pipe. So, how are you going to do this? First, we will look into making sure that you understand why we would even want to use asyncio in the first place.
Okay, let's just see what he has to offer. Okay.
Hi, this is Łukasz from HDB, and I'd like to invite you to a series of short videos where we present some parts of our tech stack. In this particular series, we're introducing asyncio, a Python framework enabling asynchronous single-threaded concurrent code using coroutines. We are contributors to Python and single-threaded concurrent code using coroutines. We are contributors to Python and its asynchronous stack in particular, as well as use asyncio extensively in the HDB server codebase. This series is intended as an
HDB.
introduction to asyncio, so if you haven't really used it yet, that's perfect. Some knowledge of Python is assumed, but don't be afraid to try it out.
Wait, HDB is an open source project? What? You know someone is compassionate for something when they have like tons of videos, like not even in.
That's running now is the first one.
Okay, I think we'll go this, but okay, so we're done with the command line. I know we were a bit slow, but I guess we'll get to speed. The thing is, I don't want to start doing this because I don't have much experience with async IO in Python, so I can't just be like, okay, I'm just gonna do this because I can do this. No, that's not how you should do it. You should have some knowledge before you get into something. So yeah, I guess we'll do that, and yeah, that was fun. It was fun doing all of this. I made all my cheat sheet as well. Right, that was fun. So yeah, I mean, take care, guys, and do you want to solve that question? Okay, let's solve it. I actually want to solve it because I was able to figure out the logic after a while after looking at it. So let's do sliding minimum window substring. And so the way this works is quite simple. First, the very first thing is what we want to do is in this edge case, so we're going to do if t is equal to this, we just return uh, and then and if we do if t is equal to this, we just return right. Right. So what we're going to do is essentially what we're going to do is we make something called count t, which will be and pretty much contains all of the elements that are in t. So we'll say for c in t count t. Now it could be 1 plus count t dot. I wouldn't do that because it may not exist. You can say get 0, get c. If it does not exist, get 0 in its place. Right? Right. Now you want to start looking into it. So if you want to store the results index and the result length, which you could have something like this. You just have to infinity. Something very large. So right, the result length. This could be anything but infinity. Right. So that's what it is. And yeah, so what we're gonna do is we're gonna do L is equal to 0 just for that. So if we say for R in range of length of S, right, and we'll also have this thing that involves something like have is equal to 0, um, have is equal to 0, need length of count t, and we will also have our own window hash map, um, right. And so what we will say is first of all we'll say window c is equal to 1 plus window dot get c plus 1 equals get 0, right. We do that, and what we want to check is if c is in count t and window c is equal to count t dot c, that means half will be equal to half plus 1, right. If this is the case, that's great and this is amazing. Now while half is equal to need, if this happens the case, what we'll do is we'll first calculate the length. So if how we calculate the length is r minus l plus 1 is less than less n, we say res len is equal to r minus l plus 1, um, and then we say res is equal to lr, and obviously right, if that's the case. And now we want to decrement it, so we want to see if, so what we do if we decrement it, we'll say window sl is equal to this, and we'll say this, right, and then we will essentially just return your s, and so we'll just return, so lr is equal to res, and we'll return s r plus 1, right. So if you see, now what we are going to do is we check, first of all put that in, and we see if c is in county, then only contributes to this, right. Then we do half plus 1. Now while half is equal to need, we'll check, okay, if it's less than the length. If it is, then sure. If it's, then what we do is we remove this, we're technically removing it, and then we do l plus 1. If it's still equal, to calculate this. Now while this is not equal, we start engulfing more, and if you run this, this will run correctly. Okay, that's not run correctly. Crazy, what's happening? um, what's happening? Is this even saved? Oh, okay, buddy, it's not running. Let's see what's going on. So we say count t. If you see this, right, this is that. Did I do anything wrong in terms of how I initialize something? Yeah, res is equal to this, and l is equal to 0, half is equal to 0, half is equal to 0, knee is equal to length of that. Right, we say for r and we say for c. Oh my god, my bad. See, this is the dumb thing I did. C is equal to sr. Obviously, that is just the variable that we're working with. And um, why is that an issue? Ah, I forgot one more thing, right? Here's the fun fact, and I forgot. This is a great thing. So what happens is, if it's equal to this, right? We want to first put in the length, and okay. So what happens is, whenever something is agreeing, we wanna improve the length, and then we wanna shorten it. Once we shorten it, before we shorten it, okay, once we shorten it, and then we recheck. So we do minus, and check if it was, then we do have -1. Okay, okay, that makes sense. Okay, I think I have to include this. But yeah, okay, makes sense. What did you say? A high performance Python compiler. Let's do something like print float infinity infinity. It translates a subset of Python. Guys, it translates a subset of Python. Is this is this okay? Um, how do you do that? NumPy aware dynamic Python compiler using LLVM is using Python itself. So that's fine and all. So I think that's all for today, and we will. I think next video we will implement Fast API. It will implement the Redis client. First, we have to learn async IO, and then we'll after that is done, we'll implement that in our Fast API applications to speed it up. Thank you for tuning in from the late night session with your one and only. See you later.